Find the equation of a line between the points A, 5, 1, and B, 2, 3. So if line A, which is 5, 1, and B at 2, 3. So we can start doing with the slope. We can ask ourselves, what is the slope of the line between A and B? So let's call this x1, y1, x2, and y2. So this is y2 minus y1 over x2 minus x1. So y2 happens to be 3 minus 1 over 2 minus 5. So this is positive 2 divisible by negative 3, which is negative 2/3. Now, there's a symmetry where every point along the line, right, has the same slope as every other 2 points. So let's take an arbitrary point P, located x, y. We'll now call this x1. Let's call this x2, y1, and I'll take the slope between P and A. So let's call this 2. So the slope is equal to y2 in this case is y. So we're looking at a point on the line itself. And that point also has a slope of the same as the slope between A and B. So there's a symmetry. So y2 is y minus y1 is 1 over x minus 5. That's equal to negative 2/3. This is the equation of a line, but it's excluding the point x equals 5. So we can get rid of x equals 5 because multiplying it out, so you get an equation that looks like so I'm going to multiply by x minus 5 on both sides, so we get y minus 1 is equal to minus 2/3 x minus 5. That's the equation of a line. It's not in standard form. Most standard forms are written as y is equal to mx plus b, where m is the slope and b is the y-intercept. But we can easily convert that by expanding this equation. So is there enough space? Yeah, there's enough space. So let's write it over here. So this will be minus 2/3 x. Minus minus becomes 5, so this is plus 10/3. And then I'm going to move the 1 to the other side, and we're left with y is equal to minus 2/3 x. And the 1 moved over to here, that would be 13/3. So this is in a standard form, but this is the equation of a line, so is this, so is this. This is the equation of a line, but it's missing one point at x equals 5. So it's missing a point. So usually people want to include the point, so we want to use this equation or this equation in standard form.